So alternative to practical. We started the topic with electrochemistry. Question 1 we did in last week. Today we'll do question 2. And I want active participation, like when I say annotate on the screen, so you can annotate on the screen. You can also use a chat or a mic to state the answer. In question 2, and the topic is about electrochemistry. A chemist heated solid zinc chloride until it became a molten. The apparatus shown was then used to pass electricity through a molten zinc chloride using the inert electrodes. A silver, a silver colored solid was formed at the negative electrode. So we have a molten zinc chloride. So we have zinc ion and we have a chloride ion. Because zinc is a positive ion, so what will happen? It is attracted towards cathode, and chloride is a negative ion, so it is attracted towards anode. The first one, name the process of breaking down a substance by using electricity. What we call this? So we call electrolysis. A Bunsen burner was used to heat the zinc chloride. Describe how a Bunsen burner is adjusted to give a very hot flame. Look, if we want a very hot flame, we want the complete combustion of the substance. And complete combustion, what it depends on? It depends on supply of oxygen. If we have a plenty of oxygen, the substance will burn completely. So for a complete combustion, what we need? We need oxygen. So here there are air holes near the top and there are holes here as well. So this is normally like known as the air hole. So a fuel is like a gas is there, a propane is there, or butane is there. It is added from here, and the air holes mix, like because of air will mix have oxygen, and oxygen support combustion. So there are air holes are there near the collar as well. So what we can do, we open the air holes. So the maximum supply of oxygen should be there. And when we have a maximum supply of oxygen, it will burn completely. And when it burns completely, as a result, what will happen? It will produce a hot flame. So that was the question. So that was the question itself, that a Bunsen burner was used to heat zinc chloride. How a Bunsen burner is adjusted to give a very hot flame. So what we should do for a Bunsen burner, we should open the air holes. So the fuel or a gas burn completely. So we should open the air hole. That is what all happen when you're using a stove. Like you can adjust the flame. How you can adjust the flame is amount of the air and the gas enter the burner. So as you adjust that, the amount of a gas enter the burner by adjusting the holes. So a different amount of heat energy can be produced, or different levels of heat can be supplied. Suggestion: explain the expected observation at the positive electrode, anode. At anode, what will happen in this case? Because a chlorine or a chloride ion is there, and it will give a chlorine gas. Whenever there's a gas is given off, so what is the observation? What you will observe, when chloride ion will form a chlorine gas. So what you will see? You will see bubbles. So the expected observation, what we'll observe? We'll observe bubbles and explain, suggest and explain the expected observation. 1 mark is for mentioning bubbles, like that is what observe. Or you can, yes, you can mention a green gas form, that's also correct. But what is the reason for that? What is the reason? Because the chlorine formed at anode. Or to be more precise, you can say chloride ions move towards anode form. So chlorine will form at anode. Suggests why the iron electrodes cannot be used in this experiment. Why we cannot use like electrodes made up of magnesium, calcium, iron? So what is the reason for that? These metals are reactive, or you can also say it is not inert, or you can also say it is reactive. Like other, what might happen? It might react with the product. So not inert is correct, or you can also say it is reactive. What would the chemist observe at negative electrode if an aqueous zinc chloride were used rather than a molten? So if we are using a molten, like example, if I write, we were using a molten zinc chloride, there was a zinc ion and chloride ion. Zinc was moving towards the cathode and chloride ion was moving towards anode. If we have aqueous zinc chloride, what we will observe, because hydrogen is less reactive, so hydrogen will move towards cathode. So the difference, what difference will be there? What will, because we have to state a difference in observation. We don't have to say a here. So different is observation. It will form bubbles will form instead of solid. So solid will not form, bubbles will form. And why the bubbles will form? Explanation, because the hydrogen ions discharge at negative electrode or cathode to form hydrogen gas. That is the reason. So what is it? What difference would the chemist observe at the negative electrode? At the negative electrode, what difference he will observe? We'll observe bubbles will be there instead of solid. And what is the reason for that? The reason is that because hydrogen is discharged, hydrogen gas will produce instead of a zinc metal. When electricity is used to break down concentrated aqueous zinc chloride, a chlorine is produced at the positive electrode. Describe a test and the observation. So you have to learn what is a test for the chlorine gas. We use a damp blue litmus. And what is the observation? What will happen? First, it bleaches, or you can say it turned first red and then bleach. Or directly, if you say it bleaches, bleach here means the color will be removed. The bottle of a zinc chloride is labeled corrosive. One safety precaution that you should take when you're using a zinc chloride. If something is corrosive, what you should do? In a lab, if a chemical is corrosive, what you should do? Wear goggles. Yes, that is one thing. What else? Hmm? So gloves. How you can avoid a skin contact? Gloves or use lab coat. So we are using tongs to hold. That's fine, but it's a bottle. You have to handle a bottle. So better gloves rather than tongs. Tongs is if is acceptable. It's not wrong. So this was question 2 related to